Before that, we have collected information about the microprocessor. Now we are discussing on microcontroller, and that is a generic block diagram of microcontroller. So it consists of the ALU and register controlling it. Then inside that single chip, memory is there, input interfacing devices, output devices, along with all the devices are there. This is called as microcontroller. Out of that, last time or in the last lecture, we have discussed about the ALU. Now we will discuss about register. Now register is what? A register is nothing but a combination of a number of flip-flops. One flip-flop, second, third, fourth, fifth. When we club 8 different flip-flop, that become one register. So I can show it like this. This is a register which consists of number of flip-flop, and every flip-flop will store either 0 or 1. So how it looks? It looks like this. This is a register which consists of number of flip-flops. This is known as register. And in that register, we can store some binary information. Suppose I want to store a number 10, and 10 number is decimal number. So first of all, this is 10 number, this is a decimal number. I wish to convert that to binary format. I will write this as a 0, 1, 0, 1. 8 plus 2, 10. And then remaining bit will be 0, 0, 0, 0. So what I did, I tried to convert a 10 number decimal to binary format. So the base of this is 2. You might be knowing the weightage. Weightage means what? Every digit from right to left has a weightage. This is 1, this is 2, 4, 8, 16, and so on. So if I want to write 10 number as a decimal binary number, in that case 8 plus 2, that is 10. So I converted 10 number decimal to binary format like 0, 0, 0, 0, 1, 0, 1, 0. And that should be here 0, 0, 0, 0, 1, 0, 1, 0. The meaning is this register has stored a number which is 10 decimal or 00001010 in terms of binary format. So what is it? I can write this as a, there are number of registers. They are either of 8 bit, or when two 8 bits are combined together, it becomes a 16 bit. So I can write this is as 8 bit or 16 bit register. It's not like a single register is there. It depends upon the variants. There will be a number of registers used. Now, why they used? Now, these registers are used for a temporary purpose. I mean, before I go for any computation process like mathematical addition, subtraction, multiplication, division, or logical operations, or and that time the data on which I want to perform the mathematical or logical operation, that data must be stored somewhere. Somewhere means either in the register. So they are being used for temporary storage of data. If I want to store a 8-bit data, I require single register. If I want to store a 16-bit data, I require 2 registers. If I want to store a 32-bit data, I will go for 8, 16, right. I may go for 4 different registers, and then in that 4 different registers, I can able to store a 32-bit data. So they are used for temporary storage of data. So this is, now for example, let me write a same program. The program is 10 plus 20 and answer will be 30. So this is my program. 10 plus 20. Answer should be 30. So if I want to write a program and want to execute the program, this 10 number must be stored for temporary purpose. I will go for 8-bit register. This 20 must be stored in some register. I will go for one more 8-bit register. And then with these two registers, I can perform the function of addition, subtraction, multiplication, division, or and inversion, whatever it may be. So, for storing of this number, decimal number, I want to convert into a binary format, and that will I store in a register like 0, 0, 0, 0, 1, 0, 1, 0. Fine. And 20 is the number that I want to store. So I can store in one more register, 8-bit register. 16. 16 means 8. 16. 16 plus 4. So it should be like 1, 0, 0, sorry, 1, 0, 1, 0, 0. Remaining bits are 0. 0, 0, 0, 0, 1, 0, 1, 0 means that 0, 0, 0, 1, 0, 1, 0, 0 means 20, over which I want to perform the operation of addition, and then I am going to get some result of addition. How to add it? Yes. 0 plus 0 should be 0, 1 plus 0, 1, 0 plus 1, 1, 1 plus 0, that is 1, 0 plus 1, 1, remaining bits will be 0. And this is my answer. Of course, for this answer also, I require one more register. Here, we require one more register. So, the registers are used for temporary purpose of storage of data before we go for any kind of mathematical or logical operations. So, that I shown over here. But before I move ahead, have you got the concept? आगे
Yes,
समझते
sir.
का?
Yes, sir.
Yeah. Yes, thank you. But then it has one more application like temporary storage of data. That concept we have seen. But then the same registers can be used for different purpose, and the purpose is called as memory pointer. Memory pointer means what? The object to which the function is assigned, and the function is to point out the memory to which we want to communicate. Now, for example, let me give you one example, real-time example over here. Suppose if you want to search a book in a library, central library, and of course there will be a separate room, a number of rooms are available. In that room, number of racks are available. In that number of racks, specific mechanical department racks, electrical department racks will be there. And then electrical department rack, number of racks are there. In that department rack, subject wise, they might have put some different rack or cupboards. Some cupboards are for power system, some cupboards are for control systems, some cupboards are for logical devices, machines, everything. In that cupboard also there are number of shells. In that shell also there are number of books. So quite difficult to find out the book. No, if you physically go in the library and start searching for a particular book like Vadva, so that Vadva book, if you want to search in the library, sometime you may feel it's a hectic one or difficult. So what he will do? He will ask to Kir sir, which is sitting there in the library, because he knows everything. So once you ask him, sir, where can I find the Vadva book of power system? He will insist you, yes, you please go to row number 4, rack number 5. And in rack number 5, in a probably, second, third shell, you will get that book. Now what he did? He was sitting on his chair. Once you ask him where to go for searching a book, he has instructed you to that address. This is the address. You please find the book. So what he has done, he he has worked as a memory pointer. He has worked as a address pointer to specify the address and directing us to go to that shelf, go to that rack, and go find that book. Similar kind of work is assigned to this register. So apart from storing a data, that is one task is clear, the same can work as a memory pointer. In that case, they will suggest us, or us means what? A programmer, that the memory location to which you want to communicate is this one. For example, जर का असा असेल, it consists of 11110000 in a binary format. Means what? If I convert to hex, address, the address will be F0. Yes, this is known as memory address. So they will point us that you want to communicate with the memory address. The address is F0 hex, means what? 11110000 binary format. So they will work as a memory pointer to point out the memory location to which that time microcontroller wants to communicate. Communicate for what? May it fetches some data from that memory. May it require to store some data in that memory. May it require to delete the data from that memory. May it require to copy the content in that memory. That function may be different. But which location? Yes, that location is being given by a 8-bit register. So that is called as a memory pointer. So to work as memory pointer. Yes, concept of memory pointer will not be clear at this point, no doubt, but just for a sake of sentence, this is one sentence. Keep in mind as we move ahead, we will put some more explanation on that topic, how they will work as a memory pointer. So this is about registers, and then number of registers are there. In some there may be 8 register, in some controller 16 registers. Depends. Number varies with the variant, so that part is different. What it is? It is a simple 8-bit or 16-bit register. So shall we go ahead? We have seen 2 points. Yesterday we have seen ALU. Now we have seen register. Davya पुढे.
Yes, sir.
Yes, sir.
Yes. Third one is control unit. A control unit is a part of this particular block. And yesterday also we have discussed on that. Because for communication, this has to communicate with memory. This has to communicate with input. This has to communicate with output, timer, ADC, serial, DMA, other devices. But for communication of every location, it requires to specify some time, and the time is assigned by a block. The block is known as control unit. So control unit will decide how much time we require or the controller require to communicate with the memory and all the other blocks in this IC. So this is to provide communication time with memory, input, output, and other devices. I think this we have seen in last lecture also. At the same time, why we require this CU? The CU will define which particular operation we are going to carry out. The operation may be of reading process or operation may be of writing process. Reading. The example was given. Now, when the professor is writing the content on notebook, this process is called as write process. Or when the professor is reading the content from the book, that is called as read process. Similarly, when data will flow from processor to peripheral device, that is known as write process. And when the data is flowing from peripheral device to the processor, that is called as read process. So, if I want to discuss about these three devices to which we can go for read and write process. From memory, we can transfer the content to processor, or from processor we can transfer the content to memory. This is called as read and write process. So this is used to generate the appropriate signal. Means what? This line is there. This will generate the signal. Signal is memory read. One more line is there. This will generate a signal. Memory write. One more signal. This will say that input read. One more signal. This will generate a signal like output write. So to generate control signals, okay, like read for read operation, it generates a signal like write WR for write operation. So this is one line. This is one line. When the line goes low, we go for read operation. This is one more line. When the line is high, nothing is going to happen. But when line goes low, given by right bar means 0. So when the line goes low, we go for right operation. Similarly, there is a one more line. The line is known as IO oblique M. Baga. And I think the first lecture said the controller or a processor will perform only one operation at one time. When it wants to communicate with memory, it will not communicate with input, output, and all the devices. Or when this is communicating with the output device, it will not communicate with the memory, input, or the devices. I mean to say that at one time a communication happens with only one device. So when we are communicating with the memory, the I/O is not to be get communicated by a processor. So why not? This is a control signal who will specify us that whether we are going for communication with memory or we are going to communicate with I/O device. Simple. If the line is high, we are communicating with I/O devices, input or output. And when line goes low, we are communicating with memory device. So this is known as I/O slash M, and M is given by bar. So means when this line, the line है ना, when the line is 1, we are communicating with input output devices. Or when the line goes low, 0 म्हणजे काय? Memory. Memory म्हणजे काय? Memory bar. म्हणजे काय? 0. So we are communicating with the memory. So this is accomplished by single wire. This is accomplished by single wire. Perhaps a selection of memory or I/O device is done by again a single wire. When this wire is high, we have to communicate with I/O devices. When the wire goes low or signal goes low, we are communicating with the memory devices. So these signals, read bar, write bar, I/O oblique M bar, these signals are developed by control unit. Now, along with ALU, along with register and the CU The entire block, this block is known as Central Processing Unit CPU. Many times students make some mistake between ALU and CPU. ALU is a typical block where we carry out the mathematical or logical operations. Perhaps the CPU consists of ALU plus registers plus control unit. The combined block is called as CPU, Central Processing Unit. Okay, I think this is enough. Please note down all the contents. Okay, Shankar said, please ask me. Okay, so one part is over. Now we'll discuss in a brief, not in detail, because memory structure is much complex and we need to study in detail. But right now, as a part of this topic, generic block diagram, I must explain it in a brief. So the fourth point is memory. See, now the controller, normal controllers are having two kind of memories. You might be having idea about it. One of them is called as RAM memory, other one is called as ROM memory. Again, in the ROM memory, there are different kinds of memories, EPROM, EEROM, and so on and so forth. But broadly, we can say that a controller consists of two memories. One is RAM memory, other is a ROM memory. So, consists of RAM memory and consists of ROM memory. So this is random access memory. And this is read only memory. Generally, the size of RAM is less and size of ROM is bigger. But then why we require this? There are two different memories. One is called as random access memory. Means we can read the content, we can write the content, we can delete the content from that memory. And ROM memory is what? Read only memory. The content placed in that memory is not supposed to be changed. They should remain fixed till the moment we want to keep them same. So they will work appropriately for processing of the controller, microcontroller. Now for communication with RAM memory, what we require? For communication with any peripheral device, we require three things. One is address bus, second is data bus, and third is a control bus. Let me show it. So to find out location, 1, 2, 3, and it consists of number of locations. Fine. And every register consists of 8 bit, 8 bit, 8 bit, and likewise. So a RAM memory is what? A stacking, or we can say a combination of number of registers which are kept in a single IC. This is suppose IC consists of register 1, 2, 3, 4, 5, 6, and so on. And every register consists of 8 bit. The way we have seen 8-bit register here, the way we have seen 8-bit register as a ALU. Similarly, these all are nothing but 8-bit registers. So size of this RAM is given by, suppose it has 1000 register, each one of them is 8-bit, 8-bit. I can write this as a 1024 into 8. Means in my memory we have 1024 register, each one of them is 8 bit. Similarly, what is ROM? ROM is also same. Register 1, 2, 3, number of registers are there, each one of them is 8 bit, 8 bit. Last be 8-bit. Again, the size of that depends upon how many registers which we have used in a single IC or single memory IC. Suppose if I say this is of 4 kilo, so means 4096 register, each one of them is 8. This 8 indicates a size of single register, and this first number indicates number of registers in a memory. In a short, we write this as a 1 kilo memory. In short, this is known as 4 kilo memory or 4 kilo B for byte, 1 kilo byte. So size of this is 1 kilobyte, size of this is 4 kilobyte. Now this is not the actual size. Actual size of microcontroller is different one. This is just given for example. Now we must find out what is the purpose. The purpose of memory is to store a data or a program. Let me give you an example. If my program consists of 10 plus 20 plus 30 minus 25 multiplied by 15 divided by 16 multiplied by 17 logically or 18 and get the answer in terms of result. Somebody asked me, please write a program to execute this one. Now in my program, I am dealing with numbers 1, 2, 3, 4, 5, 6, 7, 8. Now this is called as data. So one thing is clear. When I am writing my program consists of data. Now that data may varies. I may use for 10, 20, 30, 40. Somebody may use different data. So that data must be stored somewhere. And storing of that data is done in one memory. That memory is called as RAM memory, random access memory. Here we have to store a content called as data. Program मधला data आपण जिथे सेव्ह करतो त्याला म्हणतो आपण random access memory. Or one more name is given. It is been called as a data memory. A similar line. My program consists of addition, subtraction, multiplication, division, multiplication, or and. What is it? These all are instructions. And the state of instruction. Instruction 1, addition. 2, addition. 3, subtraction. 4, multiplication. Now these instructions are stacked together. That is called as a program. So this is known as program. Of course, from my entire program, data will be stored in the data memory. I require one more space to store the program. What to be done? I have to go for addition, subtraction, multiplication. So that instructions are stored separately. That is called as ROM. Here I am going to store a program. Fine? Because I don't want to change the instruction. Instructions must be same. Because data can be changed. So I'm keeping my data in a separate memory. I'm keeping the program in a separate memory. Yes, saying this is not that correct at this point, I know. But just to make you understand the concept of this two memory, I have done this. But when we actually execute the program, the technique is little bit different. But just to understand at this point of time, this concept is okay. So this RAM is also called as data memory. And this ROM is called as program memory. Now based on this discussion, we will write some points over here, one by one. Okay, point number 1. The memory consists of two kinds. One is ROM and RAM memory. It consists of random access memory. Second point. It consists of read-only memory. Random access memory is called as data memory. ROM is called as program memory. Data memory is used to store a typical data which is been used in a program to store the data in the program. Program memory is used to store the instruction or called as program. Store the set of instructions called as program. Size is not mentioned here because size depends upon the variant in a controller. It may change. बरं समजतं एवढं कळतंय काय लिहिलं ते
Yes, sir.
Okay, others please reply, are you there? I'm listening the answers from 2 or 3 students.
Yes, sir. Yes, sir.
Yes,
Yes,
sir.
please. Yes,
Yes, sir.
thank you. Yes, thank you. So this is about a block known as memory. It's pages. We'll go for this one. Timer. Input output is not yet required. At this point of time, you can say input interfacing device to which I'm going to connect input devices like keyboards, switches, and so on. An output device, interfacing device, where I'm going to connect the output devices like LEDs, 7-segment display, monitor, printer, plotter, in that way connected. Go for timer. Okay. Now, when I was explaining ALU, I said that it is a register. Now, when I was explaining register, I said that it is a 8-bit or 16-bit register. When I discuss memory, memory is nothing but number of registers in a single IC. In a similar line, when I want to discuss timer or counter, this is again a register. A register, it may be of 16-bit or may be of 8-bit. So, what is it? This is nothing but a single register 2, 4, 8. So, this is called as 8-bit register. Of course, all their registers, but the work assigned to every register is different. First of all, focus on this one. So timer or counter is what? A 8-bit register, or in some cases, it may be 16-bit register. So the first line is, it may be 8-bit or 16-bit register. But then the same register is used for two different purposes. The first purpose is it has to work as a timer, and second purpose is the same register has to work as a counter. But the place is same, the object is same, the register is same. So same register can be used as a timer and same can be used as a counter. Let me write here. First of all, this will work as a timer or it may use as a counter. So I can say that it may be of 8-bit timer or 16-bit timer. I can say that it is an 8-bit counter or 16-bit counter. Let me tell you how they will call as, why they will call as timer and counter. Now suppose this is the empty block. This is one register. I want to operate this as a timer. Timer means what? This has to give me the appropriate time delay which is required for my program. In my program, I said that I'm going to switch on the light, but once I put the switch on, the light should glow after 5 minutes. बटन दाबलं मी की लाईट लागता कामा नये. बटन प्रेस केल्यानंतर 5 मिनिटांनी लाईट लागला पाहिजे. म्हणजे काय? In that action of pressing the button to the actual the light delay must be of 5 minutes. Who will give it? Yes, this is a register. This register will give me a 5-minute delay, or actually it will give me some second delay. And then I have to use that some seconds just to obtain 5 minutes. That part is different one. But at this point of time, I can say that this register will give me some delay. So timer is what? To provide time delay. Normally it is in terms of microseconds or milliseconds. How to convert microseconds or milliseconds to actual minutes or in hours or even a day? That part is different one. But that will be. So normally it is in terms of milliseconds or microseconds, depends. Or I can say that a button is pressed, my motor is running, and that may be a water pump, and I want to, stop that motor after 1 hour. So the program is there. In that program, the motor will automatically stop after 1 hour. Who has given time? Time delay is given by this register. So the function of this is to provide an appropriate delay which is required for the program. Now the same register will work as a counter. Counter means what? It has to count the events. Suppose there's a classroom and students are entering into the classroom, and it is more difficult for a faculty member to write the attendance every time. So on the door, we will connect a sensor and we will count the number while the professor will go on teaching here, and automatically the attendance will get marked. How many students have entered into the class one by one, and how many students are leaving from the class. This can be monitored, and for that we require a device. The device is called as counter. So counter is used to count the events. Events count कर दो तो. Otherwise from conveyor belt, how many boxes have been passed. Like we have to count it. So in that way, it is used for counter. But for counting, there are two different way of counting. The first way of counting is called as up counting. The other way of counting is called as down counting. कैसे क्या बगा? Now this is a register who has to work as a counter. This is a 8-bit register. Okay. So I hope you can able to see it. So initially the number present over here is a 0. So it is 0, 0, 0, 0, 0, 0, 0, 0. This is initial number. And once the object is passed, the sensor senses the object. At every passing of single object, this will increment by 1. 0, 0, 0, 0, 0, 0, 0, 1. Object number 2 has passed 0, 0, 0, 0, 0, 0, 1, 0. Object 3 pass 0 0 0 0 0 0 1 1. Object 4 pass 0 0 0 0 0 1 0 0. So likewise, when every object passes, this increments by 1, 1, plus 1, plus 1, plus 1. This process is called as up counting. So I can assign the task to this counter to go for counting, no doubt. But counting should be up counting. So there are two things. Up counting. The counting can be done by different way also. Down counting. Down means what? See, in down counting, the counter or a register consists of all ones, 1 1 1 1, completely filled value. 1 1 1 1 1 1 1 1. And when the object passes, it decrements by 1. It becomes 1 1 1 1 1 1 1 0. Second passes, decrement by 1. 1 1 1 1 1 1 0 1. Third object passes, 1 1 1 1 1 1 0 0. And now the initial number minus last number should be subtracted. The moment when we subtract initial number 1 and from when we subtract the last number from the initial number, we will get a count. Count is 1, 2, 3, so like three number objects are passed. This process is known as down counting. So this may go for down counting. So counter is what? Counter is nothing but 8-bit or 16-bit register. It can be assigned as a timer or counter. Timer means to provide appropriate delay which is required for the program. And counter means what? To count the events. The counting can be done in a up way, or counting can be done in a down way also. So that's called as up counting and down counting. This is about a block that is timer or counter. Okay, please allow me to continue for 5 minutes. I want to complete this block because from next lecture I want to go for the new topic. Just we have to collect 2 3 lines from this. Now in controller, there may be, I'm not saying always ADC is inbuilt, not necessary. ADC, which converts the analog signal to a discrete signal, 1010 format, it may be inside or it may not be inside. But normally 80-90% controllers are having ADC. So what it is? It is again a register. This is again a register like this. So it is again 8-bit register, but not necessary. It varies. It may be 6-bit, it may be 8-bit, it may be 10-bit, it may be 12-bit, 16-bit, but not more than 16-bit. That is sufficient for us. So normally this is also it is 8-bit, 10-bit, 12-bit register. Now what it will do? It will convert the analog signal to a discrete format. So it is used to convert analog signal to digital signal. Now for example, बघूया आपण जरा analog signal आहे 0 volt. There is a 8-bit register. Suppose 8-bit ADC. So example wise, example wise 8 bit ADC असा असेल त्या डिव्हाइस मध्ये तर काय होईल the signal is analog and the signal is digital हे आहे इनपुट याला आणि हे आहे आउटपुट फ्रॉम दिस इनपुट सिग्नल आहे 5 वोल्ट मॅक्सिमम 0 वोल्ट मिनिमम so this is 0 volt minimum and 5 volts maximum what you will get in this register. So this 0 to 5 volt, every stage is converted to a binary format and we will get the 8-bit result for every number 0, 1, 2, 3, 4, 5 or even 0.1, 0.2, 0.3 depends. Example wise. If the volt is 0 and this result will be available in this ADC, I will get 8 zeros. 0, 0, 0, 0, 0, 0, 0, 0. When the register consists of all 8 zeros, I realize that the voltage analog signal is 0 volt. If it is 5 volt maximum number, means what? In this register, I am going to get all 1. 1, 1, 1, 1, 1, 1, 1, 1. In between that, different number of steps are there and that depends upon the resolution. The resolution of ADC depends upon number of bits. So the first digit is 0000, 0000, next will be 0000, 0001, next will be 0000, 0010, likewise the last will be 1111 and 1111. Will you please tell me, or somebody please tell me, how many different number of steps are assigned or are available in this ADC? If the register is of 8 bit, the different steps किती आहेत? Which is called as resolution of ADC. सांगता येईल?
8 steps.
Number of steps starting from all 0 to all 1. That number of steps किती आहेत?
8 or 16.
Let me help you out. 1 line, 2 steps. 2 line, 4 steps.
256.
3 line, 8 steps. Yes. If the lines or places are 8, 2 raised to 8, 256. So,
Yes, sir.
yes, the first will be 0, 0 to all 1. So, the quantization of signal is nothing but 5 volt divided by 256. I'm going to get that much of minute step sense. So, number of steps are equal to 2 raised to 8 is 256. So, the quantization is done by the maximum voltage or difference of voltage divided by number of steps. So, I'm going to get a least count. सर्वात लहान व्होल्टेज सेन्स किती होईल बरं ते होईल 5 व्होल्ट भागिले 256 एका स्टेप मध्ये मला तेवढं व्होल्टेज मिळणार आहे 0 प्लस दॅट व्होल्टेज प्लस दॅट व्होल्टेज प्लस दॅट व्होल्टेज likewise when we go for 256 number of steps we will reach to 5 volt. So in that way it works. I mean to say this is a simple register which converts the analog signal to a discrete signal and number of steps depends upon the bit size. हा जर का 4 bit ADC आहे number of steps are 16. हा जर का 8 bit ADC आहे number of steps are 256. If this is 10 bit register number of steps are 1024. And if it is a 12-bit register, number of steps are 4096. If I'm not wrong. Yes. Of course, that depends upon bit size. किती bit ADC आहे त्यावर डिपेंड आहे. because the formula is same. 2 raised to n should be equal to number of locations or number of steps. I hope हे कळलं असेल तुम्हाला. पण शेवटी काय आहे? Register. This is also a register. Okay, I think we should stop here. Just 2 more blocks are remaining. We will see in the next lecture. But before I leave, don't leave. Let me correct the attendance. Just a minute. बरं, काही शंका आहे? काही समजत नाहीये असं होतंय का आतापर्यंत?
No, sir.
No, sir.
No, sir.
Yes, you can leave, please. You can leave the class, please.